Hello?
Some spots in the northeast and New England will see the most snow. They have winter storm hail. This low that's tracking up the coast at some spots.
So I think we have given sufficient time for whoever wants to come. All right, this is gonna be somewhat of a review. Um, I see one or two students or a few students had problems doing the homework assignment. And so I'm going to sort of go through it quickly, and then I'm going to provide an example of what the exam is going to look like, the final exam. There will be two sides to the final exam. Um, first, there's going to be a multiple choice section, which is going to be open in 2 days in the morning. And then there's going to be the problem solving part of the exam, which is going to be opening on the 18th. Both the exams will close the same day, so it's up to you when the multiple choice exam opens up for you to begin that exam. Now, the the illustration that I'm going to do today, again, is going to look at how to do the last homework assignment. Okay, the last homework assignment is asking you to compare the wages of males and females. And the simple thing in that assignment, so students are asking me, how do we compare them? Well, I mean, you compare the average wage, and that is the easiest thing that we have learned to work with. You compare the average wages of males, the average wages of females, and the best comparison is just to the best way to compare them is simply to do a test of hypothesis, to plot a chart and say, look, the average male makes so much money, the average female makes so much money. And so you compare the males and the females by looking at the averages. The same thing that you do for the married and the non-married uh, uh, members of that working group. And so the question is, well, but you did not give us the information. When you look at the data, and I'm going to pull up that data. When you look at the data, you will see that the data is coded, on the gender. So I'm going to share my screen, and I'm going to share my screen. All right, so that is the data there. Actually, I changed this. Are you seeing my spreadsheets?
Yes.
Yeah.
Okay, all right. So here you see gender, okay? Uh, so let me see. I change that to gender. As you can see, the variable gender has zeros. Are you seeing that?
Mm,
Yeah, zeros on the gender.
Okay, so let me replace that. Okay, you see on the gender you have zeros, right?
Mm-hmm.
You also have ones. You see
Mm-hmm.
that? So the gender variable has 0 and 1. And so um, I see. Okay. So if the variable has a value of 0, that is male. If it has a value of 1, that is female. So for example, this particular observation, this first person is a male and makes 19,000. And the person here is a female. The female, I'm going to, okay, this is a female, and that person makes 21,000, okay? So now when you look at that kind of data and you ask yourself, how do you calculate the average wage of the males? And then how do you calculate the average wage of the females? The first thing you do then is to sort the data, okay? The first thing you do is to sort the data. And I'm going to sort the data. You paint the area you're going to sort, okay? You saw the data. You click on data, click on the sort, and you sort by gender. And so you can see all the males come first. All the males come first, and then after that, the females. So you have sorted the data, and after you sort the data, then you create a table. You can now say um, gender, average wage, standard deviation, and we had gone through this before earlier in this class, but we'll do it again. So you have a table. The gender here is male, female. All right. And so how do you calculate the average wage? Very simple. You're looking at the average wage. So the gender, the females go from location 3 to location 55. And so you come here and you use here, the average is, and the wage is in location B, So you're looking at B3, B55. And so the average male wage is 36,492. And the females go from 56 to the end, which is 202. It's easy. Go to 56, 102. So the average female makes 24,000. This is very easy to do. This is very easy to do. Then you calculate the standard deviation. We already know how to, we know where the location is. Okay, so we'll look for that. Go for statistical. Okay, so standard deviation, the sample standard deviation, S, B, 3, to B, 55. All right. We go here, 56 to B102. All right. So that's it. You don't have to do anything heroic. Now, having done this, your next step is to resort the data. Now, you have to sort the data 2 times. One based on marital status, okay? And you have to copy this right away, otherwise you're going to distort what you have. You copy this, and you paste it into some Word file so you don't lose it. All right. So you have it there. And now the next thing, again, you can actually copy it and paste it in such a way that you don't lose it. All right. So now you just have the numbers. You do the same for you do the same for marital status. So I'm not going to do that. I'm going to have you now use what we just did. Do the same for marital status. Married. Not married. And you sort the data again, and then do the same calculation. All right. In that case, you don't lose what you have. Here,
Professor, I have a question. Sorry.
yeah.
So for married, would 0 would be
Zero will be
non-married?
not 0 is not married, and
One
1 will
is
be
married.
married.
Thank you.
Okay, and so that sort of makes it easier to do. And so you go through the same process again. Now that you have the sample sizes, that's very easy. 3 to 53, you can say size of sample size. 3 to 53 is 51. I mean, 3 to 55 actually is 53. And 56 to 102 will be 47. All right. And so that's easy. So now that you have the average and you have the standard deviation, you can now do a test of hypothesis. Okay. And you can choose your own level of significance. You can choose 0.01, 0.02, 0.25. You can choose whatever you want. 2.5%, 1%. which is 0.01, 2.5%, which is 0.025. Choose whatever you want. It's up to you. My whole objective here is to get you to understand the process of testing hypothesis, and that you choose your own level of significance. Okay, so I'm going to put this. I'm going to stop sharing this, and I pull up another screen. Okay. All right. So for the assignment for week 14, all right. All right. So these averages are not true. You have to calculate it on averages, but you have the information there, and so you use that to do the problem. Okay. So now we're talking about the process. Okay. Talking about the process. The process will be first of all, you sort the data. Based on gender. Okay. Okay. Male equals 0. Female equals 1. Okay. You calculate the average wage for males and females, and then you calculate standard deviation. Okay. Again, using the Excel function. Now, I mean, you can feel free to do a calculation using the formula if you want to do that. That's up to you. Okay, and it's easy to plug in the formula in Excel. And then you do a test of hypothesis. Now that you have again, you determine sample size. Again, from the count. Okay, males 53, females 47. Okay, then you use that to do test of hypothesis. Okay, so now you have the average wage is what you call your mu. Okay. So that is the average wage for males, the average wage for females. And the test of hypothesis here is test for two population means. Okay, that is what you're looking at. You're calculating, you're doing a test of hypothesis for two population means, mu1 and mu2. Okay. Mu1 and mu2. That's what they're looking at. Okay. Yeah, so we're looking at test of hypothesis, and your null hypothesis will be that mu1 minus mu2 equals to 0, and the alternate hypothesis that mu1 minus mu2 is not equal to 0. Yeah, the average wages of males and females are not significantly different. That's your null hypothesis. Okay, and the alternate hypothesis okay, is that the average wages of males and females are significantly different. So I'm going to make this a big, okay, so as to differentiate the alternate from the null hypothesis. Essentially, this is going to be okay. This is the process for the assignment in for the first part of the assignment. This is the process for the first part of the assignment, and this is what you're supposed to do, and this is what I expect to see. Now, when when you go to do the other part of the assignment, that is regression analysis, which we have already gone through. So I'm not going to do that, but I just did this because some students were asking. I mean, you asked us to compare the males and the females, but you gave us no information. So the information is here, and your objective is to do a hypothesis test to compare two population means. That's essentially what it's about. Two population means mu1 and mu2. Okay. Okay. All right. So now, going to the next thing, which is which is your final exam. All right. Now, your final exam, okay, this is an example of hypothesis test as a function of education. Here, again, we are dealing here with a regression problem, okay? And you're going to have different kinds of problems. You're going to have a hypothesis test for two population means. You're going to have hypothesis test for the slope of a regression model. You're going to calculate means, you're going to calculate standard deviations. And so what I'm going to do for the test for you, let me just caption this, okay? The structure and expectations for the final exam. All right. So I'm going to provide all formulas. All formulas will be provided. Okay. All formulas will be provided. Your problem is to select the appropriate formula for each problem, okay? Your task is, your problem is to select the appropriate formula for each problem, okay? So you should practice on the right formula for each problem. Okay, all right. And I'm going to give you an example. I will give you an example of this that particular thing, that the particular structure and expectation. And I'm going to use a regression problem to illustrate what I'm going to do. Okay, I'm not going to illustrate every single problem. I'm just going to use a regression model to show you what the way I'm going to present you the information and how you're going to use it. So let me ask a question before I just continue. So everybody, are you guys seeing my screen?
Yeah.
Okay, you're seeing the
Yes,
PowerPoint?
sir.
Okay, all right, you're seeing the PowerPoint slides. Okay. All right. Now, I'll provide you an example, okay? An example, the example will be a regression to estimate the relationship between dependent variable, the dependent variable y, and here we're going to talk about the rate of return on mutual funds, and expense ratio, okay, the dependent variable, okay, the independent variable here and the independent variable. An independent variable here is the expense ratio. So our model will be y equal to a plus b times X plus E. All right. So in a sense, we're saying to ourselves, is there a relationship between the rate of return and the mutual fund and the expense ratio? Now, you know what mutual funds and the expense ratio is. What it simply says is the following. Now, a mutual fund is where uh, a large number of people put money together and, and invest in specific assets. For example, they can invest in equity stocks, they can invest in bonds. Now, because there is a large number of people, there's something called a fund manager. And the fund manager manages all that money. So you, me, and the rest of us in the class could put together $1,000 each or $10,000 each. We're going to have $500,000, and then we hire a fund manager. Now, the fund manager, when the fund manager is, choosing investments, there's an expense ratio, which includes their salaries and which include the cost of investing or fees and things like that. And so, for every $100,000 of investment, how many dollars is spent on expenses so as to manage the fund? And that is, that's called an expense ratio. So the question here is whether funds that have higher expense ratios also yield higher rates of return, or whether funds that have lower expense ratios yield higher rates of return. So whether there's an inverse or a direct relationship. And so we look at, say, a minimum rate of return, which is A, when there's no expense ratio, and then B is the slope, okay? So A is the intercept, okay, which is minimum return, okay? Essentially, no expense, okay? And then B is rate of change of return, for increase of 1% in expense ratio, okay? All right, so this is gonna be our model, okay? Now, our objective is to estimate A, using A hat, and I'm going to bring up A hat. Using A hat, and estimate B using B hat. And then we're going to bring up B hat. All right. All right. So now, what am I going to do in an exam? How am I going to do this in an example? All right. Let's make that big enough. All right. Okay. So how am I going to do this in an exam? And I'll use an example. Okay. The sample problem here. Sample problem. rate of return as a function of expense ratio. Rate of return as a function of expense ratio. So I'm going to this works. Okay. So my friends, so do you see what I say I'm going to do? Hello?
Yes, I see it, Professor.
You see what I'm going to do? So what I'm going to do is I'm going to say, I'm going to ask a simple question to estimate the model, okay? Estimate the model, y is equal to a plus bx plus e, all right? I'm going to ask you to estimate this model. Now, b hat is estimated using this formula, okay? B hat is estimated using this formula, but I've given you the value for summation y minus y bar times x minus x bar. That value is here. Is that clear? Hello?
Yes, it's
Okay,
clear.
it's very clear. So I'm going to give you that information, and all you have to do is to take that, plug it in here, and x minus x bar squared, that summation is here, and you take it and plug it in there and get an answer. Okay, so can somebody give us that answer?
5.16.
Okay,
What?
5.169.
None for.
All right,
Yeah.
5.1694. So you have it. All right, and a hat is equal to y bar, which is given to you 6.78 minus b hat, which is 5.1694 times x bar, and x bar is what? X bar is 0.86, which gives us what answer?
Wait. Oh, okay. I see X bar. Um,
Okay, so the answer is 2.334. All right. So what this says is that then you have the model equation. Are you able to see that bigger now?
mhm.
Okay. we have a model equation. The model equation is that y equals to a plus bx plus e is that y equal to a hat, which is 2.334 plus, and b hat is a positive number, 5.169 times x plus e. So this is your model equation. And so you write down that model equation. So my actual test here is for you to understand how to get a model equation from those statistical calculations. Once you can do that and write out a model equation for me, I will be very happy. Now after this, you have to test a hypothesis. Can we say with confidence that expense ratio significantly affects the rate of return on a mutual fund? We can theorize about it a little bit, just to give you an idea. Now, higher expense ratio can come from frequent trading and swapping of assets. And so good managers will spot opportunities for a profit, and they will swap assets. And good managers could also be more expensive, okay? And so the good managers that trade more often and see opportunities will have higher rates of return. This could be a theory for it, all right? But if they are bad managers, it means that higher expense ratios could also lead to lower rates of return. But basically, if you didn't hire managers or a manager that charges nothing and there are no expenses, then the basic rate of return on any mutual fund with zero expense ratio is 2.334%. Okay, so now the question is, the number here, this number here, is it meaningful? This 5.6169, is it a meaningful number in the sense, can we say that X significantly affects Y? That is the question in regression analysis. So we do a test of hypothesis for that, all right? Now, I'm going to copy this and go through a test of hypothesis, which we have already illustrated in the earlier slides, but let's do it again. So we have the information. Okay. This is test of hypothesis. For slope of regression line. All right. Test of hypothesis for slope of a regression line. That is what we are doing. Test a hypothesis. Now, how to test a hypothesis for slope of regression line? The alternate hypothesis is that B is equal to 0. Okay. The independent variable does not significantly affect the dependent variable. Okay. And in this case, I want you to be specific. Okay. Which is, in this case, means what? Okay. Expense ratio does not have significant effect on rate of return. That is your null hypothesis. Okay. All right. And the alternate hypothesis is that the independent variable significantly affects, or you can say expense ratio does have expense ratio which significantly affects the rate of return. So this is what we are looking at. Now, what you do then is you calculate Z equals 2 okay. B hat minus 0 divided by the standard error of B hat. Okay, I'm going to change this to B hat minus 0. Okay, B hat minus 0, and then the decision rule, as usual. If Z is greater than or equal to Z star, you reject the null hypothesis. All right. So if Z is greater than Z star, you reject the null hypothesis. But what is your Z star? All right. What is your Z star? We know how to select Z star. Okay. We have to select a level of significance. So let us say, for example, we take 0.01. And let's say we have a large sample. So Z star will be equal to Z star will be equal to 2.33. Okay. I just chose a convenient number. And you calculate the standard error of B star. I mean, B hat. We calculate the standard error of B hat. And the standard error of B hat will be summation y minus y hat squared. And we already gave you that information. Where do I have it? It's 538.93. Summation y minus y hat squared. You take it. Plug it in here. As a matter of fact, I will just take that. And this I will replace with 538.93. N minus 2. And for this particular problem, I think N. Let's see where I got that from. Yeah, N was 100. Okay. So N minus 2 will be 100 minus 2, which is 98. And summation y minus x minus x bar squared is, that's not the correct one. X minus x bar squared is 9.328. .328. Okay. And so what do we have? What we have will be the square root. Can somebody get me the answer to that problem? What is the square root of this? 538 over what? Give me the answer, guys.
I have 7.16221598.
98 times 9.328 will be 914 here. So the 914.144. Okay. All right. And so Mahamudu, what did you say it was?
I said 7.16221598. 7.1622.
7 point, thank you very much, 0.1622. Okay. That's the square root of 7.1622. I don't think so, because this is a fraction here. That's a fraction.
That's what I got.
No. 538.93 divided by 914.144
0.144.
is 0.5895, and the square root of that,
I have 51.299.
589,546. 0.76. Okay. I get 0.767.
0.767?
Yeah,
Hold on,
zero.
hold on, hold on.
Zero.
Professor, one. Okay.
Wait,
Okay.
because I.
Okay. Take 538.93 divided by 914.144.
Okay, 538.93 divided
by
914.144, right?
Yes. What do you get?
0.5895.
Okay, get the square root of that.
Square root of this.
Yeah, square root of 0.58.
Square root of 0.5895460,671.
Yeah.
I have 0.76768.
Yeah,
That's correct.
that's what I got too.
All right. That is correct. Okay. So that is the standard error of B hat. Now remember, to test the hypothesis, we calculate a Z, which is B hat minus B. So I'm going to take all of this and I'll put it in a different slide. And we're going to test a hypothesis. Okay. We already have a hypothesis that B is 0, and the alternate is that B is not 0. Okay. The alternate hypothesis is that B is not equal to 0. Okay. The alternate hypothesis is that B is not 0. The null hypothesis is that B is 0. The alternate is that B is not equal to 0. Okay. Okay. So now we take it from there. We have this information. Okay. Decision on hypothesis test. All right. All right. We calculate Z B hat equal to B hat minus 0 over standard error of B. And so what was B hat? Does anybody remember what B hat was?
Oh, sorry. I wrote it down.
B hat was 5.1694, right? Okay. And so,
Where?
which is equal to, so let's take that, 5.1694, 5.1694 minus 0 over the standard error of B hat, which is 0.767. And that gives us what? Okay, what's that calculation? What does it give us? Somebody give us the answer.
6.739.
So what?
6.739.
6.769
39.
or
739.
6.739. Okay, that is the answer. So now, according to decision rule, if Z is greater than Z star, we reject the null hypothesis, which is we reject the null hypothesis that B is equal to 0. That is the null hypothesis we are rejecting. Okay, so since Z of 6.739 is greater than Z star of 2.33, that means we reject the null hypothesis that B is equal to 0 and conclude that B is not equal to 0. Am I correct? B is not equal to 0. What does that mean? Means that as expense means that expense ratio significantly affects rate of return. And even furthermore, funds with higher expense ratios have higher rates of return. That is, as expense ratio increases, the return on a mutual fund increases. Now, that is a very simplistic interpretation in the sense we have a very simplistic model. We have a straight linear model. If you had a more complex model, which you can do if you take an additional courses in statistics like econometrics, then we can model this much better because there might be a limit to how far your expense ratio can go up and you still make a profit. There has to be a limit, okay? So that's an optimal point, but we didn't get there for this particular problem. So this is the way your final exam is gonna look like. This is what your final exam is gonna look like. You're gonna have all the formulas, you're gonna have all the summaries, all the summary numbers that will enable you to just plug in and get an answer. Now, like I said, my expectation of you, what is really going to test you is not your ability to plug in numbers, but your ability to
Application.
select. That's
Mhm.
two things. First, to select the right formula, because I'm going to include formulas that are not the right ones for the particular problem. So it's for you now to select the right formula, okay?
Mhm.
And then to interpret what is the meaning of what you have, and to go through this test of hypothesis. I'm going to test you very much on test of hypothesis. So between now and the 18th, you should practice on test of hypothesis, okay? Whether it is test of hypothesis for a single variable, whether it is test of hypothesis for two population means, or test of hypothesis for correlation, or test of hypothesis for regression. So all of that you should really practice. And we have, you can go and look at the videos we did in previous sessions and really practice on how to do a test of hypothesis. A good deal of your exam will be on test of hypothesis, okay? There are about 6 questions in the exam, in the written exam, in the essay exam. 3 of them are on test of hypothesis. 1 of them includes regression. So you would really have to try to master your regression analysis. The other 3 problems are simple problems. You could easily solve them. But there are 3 questions on test of hypothesis, which could be regression, could be correlation, it could be hypothesis for 2 population means, what have you. So this is what our exam is going to look like. Now, there is a multiple choice part of the exam, then there is the essay part of the exam. As you can see in this problem, I didn't solve every problem that I put up here. For example, I did not solve for the coefficient of determination. So you should practice on that. Maybe we can just do it here since we have it. Summation x minus x bar squared is 9.328. Okay. Summation y minus y bar squared is 538. So let's just get that out of the way. Okay, 9.328. No, this one here, and that is 9.328 times b hat, which is b hat is 5.0 1698. 5.169, 169. Okay, and that gives us what? 9.328 divided by 538 93 times 5.169 gives us 0.089. 0.089, which means that 8.9% of changes in the dependent variable are explained by changes in the independent variable, which is a very small, a very low R squared, but nevertheless, you can see that there is a significant relationship. Okay, so again, this is what your exam is going to look like. I'm going to test you on 2 or 3 things. First and foremost, your ability to select the right formula. Okay, your ability to select the right formula, and your ability to interpret the meaning of your calculations. Okay, this is not a math class. This is what you're going to encounter in the finance industry. So today is 15th. All right, so this is it. Now, any questions?
Mm,
Who's there say any question, guys?
Any questions? Go in. Go in. Gone. All right.
Rita,
So prepare for your exam. I wish you the best of luck. I want everybody to pass. The financial economics majors have the highest GPA in the School of Business. That makes me happy. We have a lot of successes out there in the industry. Students are passing the financial industry exams and getting great jobs. So I look forward to seeing all of you next semester. Those of you who have not taken a second plus statistics class, if you have taken econometrics, I don't expect to see you next semester unless you just want to enjoy another statistics class. If you have taken econometrics, the Econ 474, it's fine. But if you have not, look forward to seeing you in Econ 356, which is going to be even more exciting, more interesting, more fun, and you will learn a whole lot of new things. So, yes.
no, oh, finish it. I'm sorry to interrupt you.
All right. So, I wish you then, after I wish you luck on the exam, which is going to be finished before the 20th of December. And I wish you happy holidays. I hope you enjoy the break. Snow is falling, so at least we're gonna have, hopefully we're gonna have a snowy looking Christmas, which is the way it should be. And so that's all I have to say.
right.
Thank you so much, Professor.
Thank you.
Professor, can I email you? Because I have
Yeah,
something.
if you have problems, yeah, just send me an email. Send me
I
an
have
email.
something I'm dealing with. I have to this
Okay.
week was.
Yeah, go ahead. Send me email.
All
Send
right.
me email. If you have special problems, special issues, just get back to me.
Happy holidays to you too.
All right then. So I'll see you guys.
All right. Good night.
Good night.
All right. Good night, students.